Okay, so we're going to look at circles. See if I can move this across. There we go. Now circles are studied in this part of the functions and graphs course, and it relates to Pythagoras' theorem. So I've drawn a circle there. I've called it centre AB, which means that this value on the x-axis here is A and this value here on the y-axis is B, which matches that point. And I've got another point over here, x, y. So there's that other point, x, y. Now if I use that information and the fact that this circle has just a generic r radius, I'm going to apply Pythagoras' theorem. Well, what's the distance here? This distance here is y minus b, which is this distance here. And what's this distance here? That's x minus a. It's the bigger value of x minus the smaller one. So that's x minus a. That's the distance there. Now I'm going to use those two distances and apply it to Pythagoras' theorem. So, which says the hypotenuse squared equals the two other shorter sides squared and added. Well, each of these are the shorter sides and they're squared and added. Great, so I've done that. That's actually the general form of a circle with a centre AB and a radius R. So that's where it comes from. So if we just look at a basic one where the centre is 0, 0, applying Pythagoras' theorem gets me to r squared equals x squared plus y squared. That one's simple. That's your basic circle. That needs to go on your basic curves list. So we're going to apply the shifting concept. So you know that if you have a shift on the x, it slides along the x-axis, either forwards or backwards, depending on whether the shift is positive, which is forwards, or negative, which is backwards. So I've actually drawn a circle here. So I've given you this, and I've actually wanted you to come up with the equation. So if you look at that, clearly it's the one that was at 0, 0, and it's been moved 5 right. So what is my shift? 5 right. So instead of x squared plus y squared equals 1, it's going to be x minus 5 squared plus y squared equals 1. So that had a shift. Let's look at the next example. Can you see that the shift is on the y? It's gone up 3. So it's always y minus the shift. If it's a positive, whatever is being shifted, like the number off y, if it's a positive, I'm going up. If it's a negative, I'm going down. See this example here? Y minus the shift. The shift is 3. That's a positive, so I'm going up. So this went up by 3. How do I write the equation of that circle? So my basic is x squared plus y squared equals 1, but I've got a shift on the y, so I'm going to go y minus 3 instead of y. So that's why I've got x squared plus y minus 3 squared equals 1. Take a minute to see that this one has got a shift on the x of 2 and a shift on the y of 2, and its radius is 2. So we can see it's got a radius of 2. And then if I put those shifts in here, and we know that r squared has to be on the end here, the r was 2, so 2 squared is 4. So that's my equation there. Let's look at the next diagram. Notice that we've been shifted, that centre, look at where that centre's been shifted. It started off here, and it got moved left down there and up to there. So my shifts are minus 3 and 4. So I'm going to have x minus the shift, and I'm going to have y minus the shift. And they now replace the x and the y. They've been shifted. So there's our equation for that particular diagram. But what if I ask you, if I give you the actual equation and ask you to sketch it? Well, the first thing I would do is locate the centre. The centre has been shifted from 0, 0 to 0, 1. How do I know that? Because y minus the shift is 1. X didn't get shifted, it remains at 0. So I know at 0, 1, I've got this centre, I can draw it, and I can see that my radius squared is 1. So the radius is a length, so it's going to be 1. And then I can draw myself, this is what I tell everyone, if you're going to try and draw a circle freehand, just draw a square which is the same as the diameter of the circle. And then you can sit your circle inside it. I'm just trying to erase that. My device doesn't want to behave. Let's just get rid of that. Okay, so you can see how that sits neatly because the radius is 1. It comes down and hits here and goes up and hits there on the y-axis. Here's another one. This is your basic. This is what you build from. And then I notice I've got a shift of 2 and I've got a shift of -4 because how do I write that as a shift? Y minus a shift. So my shift down on the y is at -4. There it is there. And my shift on the x is 2. There it is there. So I've placed my centre of the circle. Now I just use the information about the radius. So this is your r squared there. R squared is 4, and it's only a length, so I'm only interested in the positive answer to that, solution to that, and that's r2. So if this has got a radius of 2, it's going to come up as high as -2 on the y scale and down as far as -6. And on the x-axis, it'll go from 0 up to 4. So it sits inside that little square like so. Next one, pause it if you need to at any point. I've put a yucky one on now. X minus a half all squared plus y squared equals 3. In the real world, we don't always have nice, neat, even numbers. So let's do one that isn't. So that means if r squared is 3, r must be the square root of 3, which is about 1.73, which means that the diameter of that circle is about 3.46. So I'm going to locate the centre first. So it's going to be at a half 0. So there it is there, because it got shifted on x but no shift on y. And then I'm going to use the information about the radius to draw a square in which this circle sits. So I know that I've got to go up 1.73 and down 1.73, which is about 3.46, and draw a square and then try and sit my circle in there. Now what if I was interested in these values here? They are my y-intercepts. We know that the y-intercepts occur when x is 0. So I'm going to put 0 into this equation here and sub it in, and this gives me this line here. Then I'm going to simplify it down, and then we know the solution to y squared equals anything gives me a plus and minus. Back here with the radius, I could have argued that if r squared was 3, then r is plus or minus the square root of 3. But remember I said we're only interested in the positive one of those because it's a length. Whereas here, I am not looking at a length, I'm looking at a position on the number line. So the position is here at plus and minus the square root of 11 on 2. So there's the plus version of it and there's the minus version of it. So that's where that circle cuts on your y-axis. Okay, so the other thing you might be interested in is what happens when you want to think about it as break it into two pieces which are now functions. Because at the moment a circle isn't a function because it's going to fail my vertical line test. But look, I can split it into its two halves. So let's make y the subject of this general form here. Here's my general form. And now, well, my basic form I should say, and now I'm going to make y the subject of that. So if you follow my steps, you'll realise I get a plus and minus square root. Well, the plus square root actually gives you the top half, so that's the top half there, and the bottom half comes from the negative square root. Okay, now take a minute to look at how that domain and range actually work. See, your x values can go between here and here, it's your domain, and your y values can go between here and here. And here, again, here's your domain going between minus r and r, and here's your range going between 0 and minus r. So they're actually described here, your domain and range. And that's it. We're going to look at exercise 5.8 next lesson. See you guys.